In a world where high-performance, zero-defect buildings are hard to find, two men are on a mission to disrupt the status quo. Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague and official agitator and friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Mr. Yoda.
Hello there. I am the agitator against the status quo. That's what everyone should know.
So occasionally we might have to pull Adam back in the line. Anyways, for today's episode, we're going to continue our exploration of indoor environmental research with our special guest, Dr. Zoltan Nagy, researcher of all things good in the world of building science, occupants, and controls. Zoltan, welcome to the show.
Good to be here. Thank you for having me.
So, Zoltan, the world wants to know what made you give up a big chunk of your life to earn your doctorate degree while all your friends were out partying. And how did you end up working at the University of Texas, Austin? You're the director of the Intelligent Environment Laboratory, is that right?
Yes, that's correct. I was appointed here last year. The story goes a little bit back. So I actually studied mechanical engineering back in Zurich at Edifice. And then I got a PhD in mechanical engineering with a focus on robotics, or actually microrobotics, which was fun, doing all kinds of biomedical research. And then I did a postdoc still in Zurich, and I moved into the architecture group and worked on building systems, but a lot on it from the architecture perspective, because I was in the Department of Architecture. And that was fun as well. And we looked a lot into, building control, but also designing stuff. And then since August last year, I moved here to Texas to start my own group.
That's very cool. So how does one go from robotics into building controls?
Well, there are many paths, but mine was essentially due to a pretty awesome project that we worked on back in Zurich, which was a robotic facade. And so we worked on, and I was leading this effort to create a dynamic facade that would, modulate light into the room, and you modulate light, you essentially modulate energy, so you can deal with, or you have to think about, heat gains and heat losses. When you think of shading systems, they're perfect for incorporating PV cells, which are coming out more and more now, thin film, so lightweight. And so we were, thinking of this multifunctional, highly distributed, small modular facade where, you'd have these individual modules that could provide shading, modulate light, but also produce electricity. And so we needed to design mechanical systems. So it was a lot of robotics. We designed new actuators, actually, that would hold it, like pneumatic stuff, and then did all kinds of analysis in a group of 5 people. So it was not me alone. But that was a good transitioning, because once you have that facade, you need to think about, now there is a people inside the room, right? So we need to consider that and create an interaction between the people. And now all kinds of things happen, right? How do you interact? When do you move autonomously? What do people want? What do we want? And so all kinds of different questions, go into your brain once you leave the field of engineering where everything is determined, there's a solution to a problem, and now people come in and it becomes just a big mess in a way. But a fun mess, right?
Those damn human people.
Right.
Who needs them?
If only there were no people, buildings would work, right?
Yes. If you want, if you want, energy efficient buildings, remove the people, right? That's the solution.
There's a theme that we're finding out with the researchers that we're talking with, and that is that ultimately these electromechanical systems that we're developing and energy systems have to be managed by people. And so, Zoltan, a question I have for you is that as this technology evolves and systems get more sophisticated, what do you think is going to happen with the facility management people that has to ultimately make these things work over the life of the building? Are we going to see skill sets change in facility managers and technicians? And if there is a need to change, is society going to produce those types of individuals as we go forward?
I think you will always need, facility management, especially for larger buildings. When you have multiple offices, multiple buildings, like a campus, for example, you need people to take care of the daily business. What you will need, what we will see more and more, I think, and I'm pretty sure because that's what I'm working on, is that, we'll have much more data support. So we'll have, buildings enter the era of big data. So you will have constant streaming of hundreds of, not thousands or 10,000 of data points. And a person cannot deal with it by just looking at all of these points because it's just too much. So we'll have systems that will support the people, but we do need to educate correctly in order to being able to use this information. So what I don't believe is that systems or these big data algorithms will somehow remove the people, because that's too far. You will not have an autonomous campus. I don't believe that. But you will have the people interacting with the systems maybe in a different way than what we see today.
There's two sides to this, though, right? There's the user experience and how much control they have. And then there's the facilities management. Now, as you were saying that, I was thinking, is there a role for AI here? Taking this huge data pile that's going to be streaming in minute, second by second, and then AI crunching that and making decisions? Is that the future?
Right. Yes, that's pretty much what I'm describing. That's kind of what we work on. There are many different levels. You can think about this, on a building level, on the systems level, that, the user in the room does not necessarily see, but the facility management sees it. Think of your air handling units, think of your, overall energy consumption, electricity data, and things like that. And AI will definitely have a role in the terms of simplifying the information, reducing to the most important things, making the information more accessible, crunching it down to the essential things, maybe ordering it, prioritizing. Again, I don't think that big decisions will be made by AI, just because I don't know if, what the level of comfort is that people will be allowing the systems to take over the management of a building. I'm willing to poke it. We're working here on the UT campus, so we'll see that shortly. But I also think that, as a researcher on campus, if I would go and tell facility management that we're taking over, they'll be just shutting the door at me and say goodbye, and then, nothing's going to happen. And that's pretty much how it will be. So there's a lot of pushback on this side.
It's called scope creep, right? For a reason.
Yeah. Yeah, exactly.
And for those that are listening, we should know that AI stands for artificial intelligence.
Correct. So just to finish my thought is there's so much going on in a building, and there's no, somehow we should not believe, and the facility management knows the building much, much better than AI probably ever will, because they know every screw in the building, basically, right? And there's no need to believe that AI will ever have the same amount of knowledge. I don't think that will happen, because every building is very different, and so you would need a totally super generalized AI, which probably will not work as good on a building, or you need a very specific one for every building, which will be very expensive to produce.
Would it become self-learning in a way, ultimately, right? You'd start with a generic AI that would learn the building it's in. I mean, even if it was taking a lot of if you took the 80-20 rule and said 80% of FM decisions are pretty basic, routine decisions, and it could do that, which left, humans to do the other 20%.
Exactly. So I think, and a lot of what we're working on here is based on this interactive feature. So you have a building and you have interactions with humans, at least on two levels. One is what you just said on the facility management level, and the other one is with the room level, with the actual occupant. And I think that what is conceivable is that you'll have, a set of rules that say, okay, these decisions you can make on your own, and then another set of decisions need an acknowledgement by the facility management, and another set of decisions, go ahead and do it, things like that. I think that's conceivable.
Actually, that's interesting, because if I was to say the FM manager for a building and my system presented me with, it says, I've done X, Y, Z routine decisions for you, these is them, and these are decisions, and these are the options around these decisions which I require you to acknowledge. That would just be an easy boom, done, then off it goes.
Exactly. So it's more to support the facility management rather than to replace him. right?
Yeah.
And this way it's much easier to work. I mean, because it gets the best of both worlds, because they don't want to deal with every little detail, I assume.
Yes.
And so routine tasks can be taken over, and then the majority of the tasks can be spent on important stuff.
So do you guys, this is a question for both of you, do you see there being another type of individual joining the facility management team? I mean, there's still the day-to-day, replacing motors and fixing valves and all of that type of stuff. But there seems to be with this introduction of AI, that now there's a need for another type of individual that both understands the technology of AI, but also the mechanics and electronics of buildings.
Oh, I've got some strong opinions on that, but I'll let Zoltan go first there, I think.
Yeah, that's a good question. I don't know. I think what we'll see is more an education because essentially what you need to do is understand how you deal with data, and that's not, I don't think you need a totally new person who enters this team, but you need the people who are there understand what's happening, and so that's all.
Yeah, I'd like to take that question then. Two parts for me. One is systems are either going to get more complex or a lot more simpler to deal with this. My view is they need to get a lot simpler to deal with this, where radiant technology will come in that, move away from VAV and 1,000 moving parts to something a lot more simple. So that takes the ability of an AI to deal with that, makes that a lot easier, a lot less maintenance. And so if systems get more simple, that's one thing. But the other thing is this, is there a new role for a data scientist in buildings? Possibly. But, people talk about BIM and Revit, and that's great. I'm on board. I'm on the Revit train, big time. Woo woo. But this is the problem with it. There are two major problems with this. It's too freaking expensive because it's a monopoly. And until the Yoda of Revit, all the way down to an FM guy who changes a filter, can use it properly, it has to be so easy to use that a maintenance guy or a technician can just walk up to it and just extract what they need out of it without having to go on a 2-day training course. That is the nirvana. How we get there, I don't know, because it is not at all in the interest of anyone who sells Revit or CAD to make that happen. Right?
Yeah.
So there, and if you're anyone who is working for Autodesk, please take note. There's a revolution coming.
Pay attention. So we want to come to the paper that you're going to be publishing, but before we get there, tell us a little bit more about what you're doing. And there's some changes going on at the UT Austin, I understand, and within the Department of Energy or Engineering. Isn't Dr. Corsi, is he leaving, I guess, or is he taking a sabbatical? Or
he's stepping down as department chair. So his tenure as department chair finishes, I want to say, end of July, I think, but I'm not sure. Yeah. But that's all. It's not. There's no revolution going on.
No. So one of these days we'll have to get him, or maybe get his dog on. Well, maybe we'll interview his dog.
Both of them.
The thing with academia, right? Everything is evolution, not revolution, right?
Right.
Yeah.
So tell us what you're doing at the UT.
Well, teaching is a lot, but for that works here, it's basically what we just discussed, kind of pretty much on time. So, on topic, is thinking about how we can use the data that's around us all the time and record it all the time more efficiently to help, facility management on one end, but on the other hand, also help the people be more comfortable in the rooms, in the buildings that they have, and also, which is what we want at the end, is to use less energy, right? So we have this kind of trade-off between being very energy efficient, which is, turn off all the lights, don't use the thermostats, remove the people, and then that contradicts with, use your office for what it's there and work in it. And so that's the balance that we're working on, and doing it with data, because the other thing is, like I said before, we generate a lot of data, but paradoxically, it's not really saved. So, not everywhere. UT does a great job. We have a lot of data, but if you go on other commercial buildings, maybe you have data that goes 2 weeks back, 2 months back, if you're lucky. And otherwise, you lose it, and it's a sad, because, you can learn a lot from the past, and you can extract a lot of information without having to do much, actually, but just looking at your data, even if it's just on a building level. And so we're trying to work in between what are the right algorithms to use, how can we demonstrate things in buildings, and actually do stuff. So we're trying to do the controls in buildings for thermal or lighting in different capacity.
Okay.
And in simulations.
So we have a ASHRAE Long Beach is coming up and we have a seminar on what came first, thermal comfort or energy. And so much of the world of property development and architecture and engineering has been so focused on energy conservation, and the world of comfort has sort of not even hit people's radar screens. But ultimately, it's a person that senses the environment, has a perception of the environment, and will control the energy systems. So I need some ammunition for this debate, Zoltan.
Well, so
whatever you tell me, if it's good, I'll use it. If it's bad, I'm not going to use it.
Oh, it's great. So listen, okay. And that's perfect. So because, like we said in the beginning, I was not educated in the building field, right, which I take as an advantage. So I'm coming in like from a sideline, basically, and get a different view on things. And in order to do that, as in science, we have to review literature, right? And so because the other things is always like discussing with people like you guys to say, oh, something's wrong, the things are not working correctly. But for the scientist or researcher, you need proof, right? I cannot just go by people's opinions. And so when I started, in August, I sat down with my student and said, let's just review the literature and see where we stand on thermal comfort compared to, building energy and energy control and building control with respect to energy. And so he goes away and he comes back a few days later and he said, I just way too many papers. I found like 5,500 or something papers by just looking the simple search terms. There's no way I can read this. But here's another idea. Let's do some, again, AI, artificial intelligence, data mining, text mining on this data set and see what we come up with. And so we used, this data set, basically downloaded from a scientific database, Web of Science, all the papers related to thermal comfort, or that would come up with the keywords thermal comfort, and that would come up with keywords related to building control, energy control, and use it a quantitative approach to see, okay, which words come up very often, which words come up together. And then we plotted these. And so the first thing is, to answer your chicken and egg problem, the thermal comfort related work dates back to the late 19th century. So the first work was on thermal comfort, on ventilation, and it was for disease prevention, right? So make a correct ventilated house in order to reduce, spread of disease. And so that's really where the first works are that are traceable in this database.
So what date was that then? Did you say?
I think, and I would have to look it up, but I think it's like 1890 or something like that. I want to say that, or 1820 actually. So it's 19th century, Napoleon times.
Wow. And those would have been probably studies or documents published by physicians at the time, I would think.
This would be, things like that by doctors, people studying heat also. That's the beginning of, or middle of thermodynamic studies too. So it was people understanding science of thermodynamics, of heat, ventilation, and how that related to people. And they saw that if they open the windows, they get less sick.
That makes perfect sense because it coincides with, certainly in the UK, for example, an industrial revolution of the migration from agriculture to industrial concentrations of people in cities. That makes perfect sense, actually, when you think about it.
Correct.
Adam, is it true that in the UK, when they had pollution problems, that their solution to the pollution was to actually build taller chimneys so the plume ended up in someone else's country?
Pretty much, yeah. That still goes on today, right? Do you know what that goes? That theory happens today with nuclear power plants and having them on the coast blowing a certain way. So all the French ones blow onto England. It's just things, the old guy is the new guy, things just don't change, right?
So anyways, sorry, Zoltan, we told a sidebar discussion.
Right. Oh, that's fun. But then it continued, right? We have the early studies on thermal comfort in the 70s in Denmark, Ole Fenger's work, and that established a scientific basis on how people perceive comfort in a very quantitative engineering way. that's really where it started. And the energy came a little later with coincided with this, with the energy crisis in the 70s and oil embargoes, where all of a sudden energy was not, free anymore or endless or so on. And you can see that the papers start coming up with, we need to save energy, we need to be more efficient and so on. And up until the 90s, actually, there was more work on energy-related work, energy-related papers, very little. So the total amount of papers is very little until the early 1990s, mid-1990s, a little bit more on the building energy side. But then from, let's say, 2000 on, it explodes, and you have much more papers or work on the thermal comfort side. It starts with thermal comfort, then building energy sort of takes over a little bit. The overall level is very small, and then it flips again. More people work on thermal comfort judging by the amount of publications. Yeah.
Well, it's interesting because in my mind, I'm sitting here thinking, so what is the leading indicator here? So it seems to me that the academic community is reacting to a phenomenon, right? Then they do research and they try and address that phenomenon. Then the phenomenon evolves into something else. So there's always a catch-up thing going on here, right? So, you're seeing the energy coming into focus in the 70s, which makes perfect sense, and the way cities really grew in the first event of mega cities at that point. And now you're getting possibly back to comfort as a driver.
Right. Now people are rediscovering those works. You have still energy a lot, so the both works develop at the same rate. It's just much more, output from the thermal comfort community. Obviously, energy is again an issue today with, pushing towards renewables. And then now the control community discovering the problem of building control on their own. So in the beginning, the control problems were not as developed as they are today. So a lot of the explosion today is based on applying the established control science onto buildings. Right, which is a problem on its own, but that's what we found in this work in the end. So we looked at basically how close words related to thermal comfort are related to building energy and building comfort kind of thing. And like I said, when you plot these words, how often they occur and how close they are, you'll see that things like PMV, so the predicted mean vote, or PPD, the percentage of people dissatisfied, which are measures for thermal comfort, are like as far away from building control like BuckNet or building energy management or sensor or even smart building as possible on this map. Yes. So we have thermal comfort on one end, we have building control on the other hand, and in between we have things, like IAQ, we have materials that sort of fill up. And then in recent years, we have also urban studies that people started studying.
So Robert's getting excited here. I can see this. I think you got something to say about this, Robert?
Well, it's so bizarre that the controls ultimately are the ambassador on behalf of the occupants to the HVAC system.
Right.
And yet the controls, as that ambassador, don't speak the language that the body speaks.
Right.
There's no recognition of mean radiant temperature, for example, or operative temperature. None of the big control companies, and I hope these guys are listening, because they don't produce an operative thermostat. But ultimately, how the body experiences the space is an operative temperature. And for those that are listening and don't know what I'm talking about, welcome to my world, because so many practitioners haven't got a clue about what operative temperature is. So in simple form, it's the marriage between what the radiant temperature experience is in the space and the air temperature. And it's a little bit more detailed than that. But 99.9% of all thermostats measure dry bulb temperature, air temperature. They don't even recognize that radiant exchange. And 60%, and you can write this down, anybody that's listening, at rest, wearing normal clothes, 60% of the exchange that an occupant has with the space is via radiation. That has been documented in medical textbooks, in indoor environmental ergonomic textbooks, and it's in the ASHRAE handbooks. So why do we let a device, which speaks for us on our behalf, it's inadequate. It's dysfunctional.
Right, and that's what we find. That's literally the outcome of the study, is that there is everything the colleagues in the control engineering community, how they deal with the problem is so abstracted as, okay, our target is to maintain a certain temperature or band of temperatures in a house. which is fine for the control problem, but it's not fine for the comfort problem, right? And that's what it seems. That's what it seems. That's what's a little bit contradictory, but also that's what gives me a little bit of job security. So that's where I'm working at.
I can't be mad at that. I understand that logic. So here's a question: is thermal comfort on one side and energy conservation on the other side, are they compatible bedfellows or are they incompatible bedfellows?
I think, well, like what Robert just said, I mean, if you look at the physics of things, right, most of the time when you're sitting at your desk, you're radiating off heat. And so, but what we also know is what you said early on, if you have radiant heating or radiant cooling, you can use much less energy or low exergy systems,
yes,
which do not need, or which you can basically use environmental temperature or almost close to environmental temperature or geothermal temperature to heat or cool your environment almost no matter where you are in the world. And so actually the two are perfectly compatible. You just need to do it, I think.
So herein lies the revolution. If you're listening to this, or you guys up there with your Che Guevara poster on your wall, right? There is a path dependency, particularly strong in North America, where the industry and the supply chain is geared to stick in rooftop air handling units on top of crappy buildings, right? And to get these two things to work in harmony, thermal comfort and energy, you need to use low exergy systems like displacement ventilation coupled with radiant heating and cooling with proper envelope, right? That's it. Right. It's not a secret. Everybody knows the solution, right? But
it's also green. It's also much greener in a way, right? So it has to happen almost. Like there's no way around it, I think.
So I've been thinking that for 10 years, but it doesn't happen. So why not? My conclusion is path dependency, fear of change. I don't know what it is. Lobbying. What is it?
It's probably all of the above. But for sure, it's a certain inertia. I mean, if you have a huge industry working in a certain way on many different levels, right? It's hard to change it all at once. But we need demonstrations, and then we need, like with every technology, people spearheading, demonstrating, showcasing, and other people willing to try, and then it will change. And essentially, the minute it will become much cheaper, it will switch.
Yeah, there's almost an analogy here with electric cars coming up as a challenge to the petrol car, right? So, you beat a bad idea with a better idea, right? But that better idea has to be really, to get a fold, has to be better and cheaper. So demonstrably so that you can't ignore it, right?
Correct. Yeah. But you can see it in another field. Or immediately here in Texas, actually, it is an oil and gas state, right? But as soon as solar becomes cheap, it will flip and people will use it. So it's the same thing, just on a different level.
I think we should bring to attention, again, to our listeners, we use the word here, exergy. That's not a spelling mistake or an auditory mispronunciation. So most engineering programs, at least that I'm familiar with, don't actually get into exergy analysis. And so in a real basic way, it's probably the best way to explain it is that when we use combustion-based systems, we're generating industrial-grade temperatures, 3,400 degrees Fahrenheit or 1,700 degrees Celsius. What we know to condition buildings is that we need temperatures that are actually at or below what's in the human body. We don't need 1,700 degrees Celsius or 3,400 degrees to condition a building. We need 100 degrees Fahrenheit, or 40 degrees C or whatever that is. And so when we use oil or gas, propane, anything that burns, we're generating with a limited resource high temperatures that we never actually extract all of the potential work out of it. And as such, we can have combustion systems that might be producing 97% combustion efficiency, but in an exergy analysis, they might be getting 6% efficiency. And we can't continue to do that as a society, to use limited resources to create industrial grade temperatures for non-industrial grade applications. And that's where I think things like, solar comes into play, wind. These are all hydro, all low exergy energy sources, and they just marry up with radiant so well. Your point is very correct, and same thing, Zoltan, with what you said. So I just want to clarify what that exergy was all about.
No, that's well said. So, putting my crazy Christopher Walken head on here, we need this industry, please, anyone who's listening, tell me where the Elon Musk is. We need our Elon Musk. You know, Elon Musk is an outlier. He's Iron Man. How that guy's not been assassinated by some lobbying group, I don't know. I mean, he must have so many people angry at him at the moment, you know, the petroleum industry, the car industry. But, you know, the building industry needs that guy. I know he's doing solar roof tiles, but that's just a small portion, right? We're talking about the whole pie here. We need that guy. If you're out there, please come forward.
So, Zoltan, this paper that you're in the process of getting published, and I'm looking at the graphic as you shared it with me, and anybody who's on Twitter, I probably can get their hands on it, I'm guessing, right? Yeah. Right. So what's your Twitter name again, Zoltan?
It's at Zoltan Nagy, except the O is a 0, because it's a very frequent name. I had to change the O to 0.
So what we'll do for listeners, we'll put all Zoltan's contact information on all website. Social media in the show notes, so you can click on it and follow his work.
Yeah,
perfect.
So I'm looking at this illustration, and of course, a picture tells a million words in this case, because there's just, I mean, you looked at, like I'm looking at some of the words here: indoor air quality, indoor environmental quality, habitation, health. All of these search words that we're using, and then that's on the sort of the center left, and then on the right hand side was all of the BAM and building control sensors.
Right.
Why do you think that the control manufacturers and the people that do research work on controls have ignored the environmental metric that's so important in buildings?
Oh, that's a good question. I don't know. I would like to hear an answer. I think it's just tough. I mean, that's what it is, right? You have to start dealing with people in buildings, and that's just difficult. I mean, that's how it is. Even what we understand, so the PMV or the PPD, the predicted mean vote, is a number that, represents how, let's say, 80% of the people will understand or feel in the space in a particular location. So it's an interesting or probably useful tool for designing a space, but then operating it with one particular person in that space is again a different story, because he might be not part of those 80% who like it. And so to deal with this uncertainty in a very systematic way is difficult.
My theory on this is there's a concentration problem in building controls. You got the big players, Honeywell, Siemens, but there's not enough competition there to really force innovation. So at some point, one of them has to break ranks and do something, right?
The other thing is also, which is another paradox, which is not in this plot or not in our word, and you guys are the practitioners, so maybe you want to jump in on this one, but, when you present, or when these companies come and present you the bill, they say, okay, this is the energy, whatever, this is what we will charge, and here's how it will operate. And there is no line on that says comfort, for example, right? It just doesn't pay, I guess. I think that's just a hypothesis. And the people who pay that bill do not, I guess, care about comfort in that sense, other than it's, you maintain a certain temperature, which is again paradox, because if you look at where you spend the most of your money, if you own a building, whether it's, university or it's a bank or whatever, it's, a big chunk of that goes to your people and not to your energy bill. And so ignoring the comfort of the people seems contradictory to me at some point, because if they become sick and if they don't come to work, if they're not productive, then, you will actually lose productivity and money in the end. And the Center of Built Environment in Berkeley did tons of studies on this, that you can have very little impact or a very large impact with very little interventions just to make people comfortable in their building, not necessarily on the energy side, but also how you design a space, which is a far bigger problem when we get into architecture.
The problem there is that the constituency you're talking about, which is massive, has no vote or money, right? So there's no consequences in the game for the owner to listen to them, right?
Right.
Whereas the energy bill is objective, it's measurable, it's easy to understand.
Exactly.
Now, the other problem with comfort is it's hard. I mean, Dr. Olo Fenger did a lot of work on that, but it's really hard to objectively measure that, right?
Absolutely.
Now, if people rated or somehow had to pay to be where they were, then their decision-making process would be a bit different, right?
Right. There is just no stake in it. That's all, right? Yeah.
Well, I think there's certainly buildings out there now in the inventory of finished projects that were built with the occupant in mind. And I don't know if we've talked about them, but if you think in terms of in Canada here, the Manitoba Hydro Building, in the US, you have the Bullet Building or the NRL Building in Colorado. And there's other ones out there that those buildings were owner built. They were, they're going to own those buildings, they're going to operate them, and they have to bear the cost of the productivity or loss of productivity, Zoltan, as you were referring to earlier. So they have a completely different ethos in looking at the architecture.
Right. And
somehow we have to be able to transfer that over into those that are building spec buildings, that's the other end of the spectrum, right?
Right. And that's part of, so we just got there. So when you're designing buildings, and that goes out to our colleagues in architecture as well, not to forget that they're designing the space for, people and not, the looks or whatever, but just how the environment also will feel afterwards to them. So they keep that in mind, that it's not something that comes after they're designed, and then there is an engineer that will say, all right, so here we'll put all the MEP or whatever, but it's actually an integrated process where you have to think about things like what you talked before. If you want to have radiant, you need to think about the surfaces, but it's not the engineers who will think about them, it's the architects, right? So we need to get them at the early stage at the same table, which again costs money and it pays off in the end or later. So it's not going to happen anytime soon, probably. But I wanted to add one thing though, that even though right now, and like you said, there are project being finished with these things in mind, there's also a lot of colleagues of mine working on these issues and publishing very recent work and things like that. So how can we directly incorporate people's behavior into the control loop and modify automatically? So there's great work coming out of, in California, in CMU, Carnegie Mellon. We're doing great work, obviously, but all over the world, in Zurich, my former colleagues. So there's work coming out, and it will just need a few more, years or generations of people educated who will go out in the field with this kind of thinking to, change the world.
That's my hope. That's what gives me optimism, actually, is that I'm hoping, certainly I look at my children who are in their early 20s and sort of finish up university, and they're not going to put up with the BS that we put up with, I don't think. They've got a very different idea of what's right and wrong. I'm a baby boomer, probably the most selfish generation ever to walk the earth, right? I always say to my kids, you could be cleaning my mess up long after I'm gone.
Yeah, that might be the case.
But what gives me hope is, one, they're aware of that, and two, I don't think they're going to put up with the stuff we put up with.
Right, there is definitely change, yeah. And we're changing, so what we started, so back in Zurich, the group I worked with, we tried to start, or the professor there, Arno Schlueter, he tried to incorporate architecture into engineering directly, so in the design process. What we try to do here at UT is, so I'm in the civil engineering department. My wife actually is teaching in the architecture department, very similar topic on building systems. So one of these semesters we'll throw all of these students into one big group and, get things going from both perspectives, right? Because it's also a cultural issue between the disciplines. We have also, this year or next semester actually, we'll have the capstone projects of the engineering students and the architecture students will be one project. So they'll work on it together, which I think is also a big step forward. There are not so many schools that do this stuff on this level to get, these things going on. Understanding that this is a big issue and things need to change, and this is the way to change it.
There's one profession that hasn't been mentioned yet, who I think plays a vital role in all of that, and that is the interior designer. That is a separate profession. And when you think in terms of materials of construction, interior materials of construction, outgassing is directly related to their decisions. Thermal comfort, believe it or not, is related to their decisions, because color in the infrared spectrum is either an absorbent or a reflector or somewhere in between. So choices in color are going to affect heat. Choices in materials will affect particulate generation and outgassing. So, and then for those that know a little bit about radiant design, because the conductivity of the fluorine material has an impact on fluid temperatures, therefore it has a direct influence on the efficiency of the cooling and heating plant. So we never underestimate the power of an interior designer. Some people call them interior desecrators. Not my words. I think it came out from John Straub. I think Dr. John Straub maybe said that word once to me, but they play a vital role, and I think we need to incorporate them in that discussion of integrated design.
You could wind up getting trolled now by some interior designers.
Please, it wasn't my words.
But the message is clear, right? And that's also something that needs to be addressed in the traditional way of how buildings are, designed, commissioned, built, or built commissioned. In that they're not linear, but you have to get all the stakeholders early on in the design process to create something truly integrated that takes care of all of these things, basically.
Absolutely.
And that's, we change it in the university educational level to the people know that it's actually useful and important. And hopefully enough people again, you create a critical mass in companies that they will change it as well. And larger companies are doing it, so it's good.
Okay, look, we should wrap up now, but I'd be very interested in getting back in touch with you in a little while and seeing how some of these projects come out, because universities have a unique ability to have this brain trust together, and then some of them are so well endowed. What university in America is not building a building, right?
Yep.
A campus is just a forever project, right?
Correct.
So, hopefully some of this thinking will fall into the projects. I'd love to see some of these ideas put to work there. And maybe do a case study on it. So we'll keep in touch with you. We'll put your contact details out there for everyone to see and follow your work. Have you got a website people can see?
Yes, I do. nagy.cae.utexas.edu.
Okay, well, again, we'll put that in the show notes for everybody.
Right.
Okay, well, thanks for speaking to us. It was very, very interesting because you have the ability to influence minds, man. That's a powerful job.
So, Adam, that was a great discussion we had with Zoltan Nagy. So what did you get out of that?
He was awesome, actually. I really liked him. It was interesting because sometimes I'm a bit yin and yang with academics. Sometimes I think they're too academic and they're not in the real world, but his research really seemed to be impacting the real world. He seemed to be in touch with what was going on. I love the historical research he did as well there, tracking the thermal comfort and energy issues and how they sort of in separate silos and still are, amazingly, 200 years later. How is that possible? Yeah. What is going on?
I know. Crazy.
But he was good. It was interesting research, and at some point there has to be resolution to this, right? There has to be a resolution and a coming together of the thermal comfort issues and the energy issues, because it's just not really happening. The well-being standard might be taking it that way. Even LEED might be taking it that way. But at the moment, it's an either-or situation to me, I think. What do you think?
Yeah, I agree with you. And as we said in the interview, that energy has drawn the attention of so many people and influence in it, that there's focus on, the mechanical efficiencies and the electrical efficiencies and the enclosure efficiencies, and have not totally ignored thermal comfort, but it's been a side discussion. It's that topic over there that belongs to the people, those crazy humans that have to make the building work. And so I was really happy to hear Zoltan talk about how, he's back in the 1800s, that thermal comfort in terms of their literature research, there was a lot of papers relative to the time. And then on the continuum, that was sort of replaced by research work in energy and controls. But there was this canyon in between the control responsibilities and what they're actually for and the comfort research. And then I was really happy to hear him say that was coming back, that there was more thermal comfort papers being published. That tells me that people are starting to pay attention. Okay, we've discussed this energy thing enough. We know how to control buildings. Maybe we're not using the right control systems, sensors, and that maybe some of the manufacturers that are listening will produce those sensors, and ultimately we'll see a merger of the world of building science, the human sciences, the control sciences. And I that's what I got out of it. That if Zoltan had a vision, and if that was it, a coming together, finally a resolution, as you talk about, then I'm all for that. I think that's a wonderful, wonderful vision to have.
Well, I think your thinking and work is really sort of in that space, right? You've always been talking about thermal comfort as a driver, low exergy systems as a driver.
Right.
How do you get that? The question is, how do we get that mainstream, right?
Yeah. Yeah. And the fact that he mentioned exergy was great. I'm so glad he did, because that really, I think at the end of the day, ultimately, our generation and the generations before us will be judged by our exergy efficiency, not our energy efficiency. And it'll be embarrassing. You know, we've talked about before. I mean, I would love to have another lifetime or two, because I would like to see what happens to mankind over the next couple hundred of years. And, I just know that in order for the humanity to survive, that we have to look at it from an exergy perspective.
Couldn't agree more. And so for those of you listening, you should be very clear that Robert and I are not in the Green Taliban. We're not tree huggers. My car is about as environmentally friendly as a hole in the Amazon basin. So yet we care and know these are issues, right? So please realize this: we are not flip-flop wearing tree huggers.
No. And no bad about it. No, I'm not a tree hugger by any stretch of the imagination. But I do know, Adam, that I went through a philosophical change probably 10 years ago, looking at my life and how my life uses resources.
Yeah.
And there were so many things that were happening, with transportation, vehicles that we had and things that we did for entertainment, and places that we needed to have to make us feel comfortable without feeling claustrophobic. And so I'm talking about big houses, boats, and big trucks.
Yeah.
And I had a philosophical change that I said, this is not right. I mean, I live in an area where I can walk to everything that's in my neighborhood. I can walk to the gym. I can walk to the grocery store. And so I've started to do that. I've incorporated that into my life. And, we got rid of the boats and the big trucks because we don't need it anymore. The problem for me and for you, because this is your problem too, is that we use the airlines a lot.
Oh, yeah. I have my own personal ozone hole. I abuse airplanes a lot, but you and I are blessed, right? We're fortunate enough to live in North America where the good life is available at a low price, but the price for that is not fully priced in, because it's a price future generations will pay. Don't want to sound preachy here, but you had was an epiphany, right? There's a word for that. It's called an epiphany.
Yeah.
Hashtag stay woke. But, it's true. You can't carry on this trajectory. If you extrapolate out on a straight line of where we're going now, it doesn't end well. Something's got to change through technology or habit or culture, or probably all them things, right?
Yeah.
And I'm at the back end of my career. This is something for young engineers to solve, right? But they got to be aware of it, I suppose, to get on it, right? And he was certainly in that camp. So good for you, Zoltan, man. More power to you, man. Keep going.
Well, yeah, absolutely. And you have a young daughter that's in engineering.
Yeah.
And, we have to put our faith in science. Despite the political
It's a very rational approach, sir.
So, but you know what I mean? The young engineers that are in university now, coming out of university, they're going to have to come up with solutions, not only to the future problems that are going to be facing them, but also to fix the things that we've screwed up in the past.
Oh, yeah. Yeah. I mean, the only way to do that, my message to any young graduates out there is get your fundamentals handled. Understand that you need to apprentice under someone wise and old, but try not to take on their mindset. You've got to agitate for change. And you got to avoid path dependency. Just because it's always been done that way doesn't mean it has to be done that way going forward, right?
Yeah, well said.
And you don't have to be a revolutionary to do that. You can just be clever and innovative, right? Elon Musk isn't a revolutionary, but some people will call him that, right?
Yeah.
If you're in the business of selling petrol cars, he's your worst nightmare come true because he actually might succeed. And there is the equivalent in HVAC and buildings all over the place. So, as a rallying call to young engineers, I say, get out there and make a difference, man. My generation didn't do that too well, so hopefully yours will.
Yeah, and hopefully the engineers coming out of university and colleges won't be faced with ethical dilemmas like some of their predecessors have been faced. And I think of the lecture that Professor Roland Clift gave on engineering for sustainable development. And if you can get that, we'll listen to that lecture. And he talked about engineers that were employed by the Nazi regime in designing the ovens, and how those engineers were basically faced with, if you don't do this, then we will annihilate your own family. And, and those ethical decisions. So when I think about engineers coming out of school today and practicing within a free world system, where no one's there to threaten to kill you, things can be pretty tough, but you still have an honorable profession, and hold that close to your heart and stick with your ethics.
Yeah, right. Engineering is a force for public good. That should never be forgotten, man.
Yeah, absolutely.
Right? Yeah. So let's wrap up. Have you seen anything on the social media lately that's rattled your cage or got you excited?
Yeah, just a continuation of architectural follies.
Architectural pornography everywhere.
Yeah, it's all over the place, and which is good and bad. And the architectural profession recognized a few years ago that they were taking a hit to both sides of the head. It wasn't a 2x4 to the left; it was a 2x4 to the left and the right. And and I think we're seeing municipalities across North America responding with enforcement of energy codes, better building construction. And part of that is a response to the abuse that guys like you and me have been throwing out. And we're just two peas in a pod. I mean, there's some bigger voices than ours out there that have been really slamming these guys. So it's a tough profession, but I think the pressure that they're under is starting to create change. I think they're starting to see it. At least I have to have faith that they're going to see it. That they need to change. For
good or bad, architects are the tip of the design spear, right?
Right.
And unless they start embracing a more holistic design approach and having engineers with them all the time, it's not going to change. So they're right to be attacked, and they're right to change and evolve. And good for them guys that are doing it. Yeah, I agree. Yeah, absolutely. Interesting. I've been thinking about project management recently. I read a great book by an ex-Navy SEAL called Jocko Willink. It's called Extreme Ownership. He is a proponent of, just own it. Good or bad, embrace the suck, right? Then he there's a great chapter in there about team management, and in his world, there's no bad teams, there's just bad leaders. So that's, I'm thinking about writing a blog on that, about scaling that up to projects, because you go on a project and people say, oh, this is a bad project. No, it's not. It's just been some awfully bad management and leadership decisions made that have led it to be bad, right? Yeah. And the more I take on Jocko's ethos, the more you see that he's right. There are no bad leaders. There's bad decisions made. There's bad budget decisions made. There's weak design engineers who won't stand up to clients. Sometimes you got to say no, right? Yeah. Easy for me to say as a semi-retired guy with nothing to lose, right? But, someone must have some testicles out there. Yeah, well, if you want to grow some testicles, you got to listen to Jocko's podcast, right? Yeah, you put me on to him. Yeah, he's great. Yeah. You listen to a couple of podcasts. Do you want to share some of the other podcasts you listen with the listeners? So I'm a big fan of comedy, and I'm a bit of a political whore as well. So I like, I listen to The Fighter and the Kid. I listen to Bill Burr for comedy, always. I listen to Joe Rogan just for life philosophy and badassery, and I listen to Jocko just to make me get out of bed and not be a wuss. Those are the ones I always listen to no matter what. And the other one I really like is the Kevin Pollak Chat Show. He's a comedian who does the best Christopher Walken impression and the best Captain Kirk impression you will ever hear in your life. If you close your eyes, you don't know it's not them guys. So I recommend all them podcasts to people. They are brilliant. And they keep there you sane. Go. That's coming from the mind of Yoda. Yeah. So there you go. That's what keeps me safe and sane. Good. You've got to have comedy in your life, and you've got to have discipline. And I need both of them to balance me out, or I go a bit off message. Those are some great words of wisdom to end this podcast. That's awesome. Adam, thank you as always. Always a pleasure. Okay, mate. Till the next time. Take care. All right, man. Take care. See ya. Bye. You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.